The Minnesota Science Standards are up for review this year, and by May of 2019, we'll likely see a final draft. This quick video aims to answer a few simple questions. Why the shift? What are some specifics I can wrap my head around? And what's the timeline for all these changes? So, why the change? Minnesota has a practice to revise standards about every decade, and it's science's turn. The Minnesota team was directed and eagerly accepted the direction to align the next draft as closely to the next generation science standards as possible. The framework for K 12 science education, which can be found on the District Science Curriculum Review page, gives a much more in depth explanation of the assumptions that guided the development of the standards. In short, that framework uses research on science learning and instruction that has occurred in the past 15 years to present a new vision for science standards. 20 states in the nation have already adopted the NGSS, and continuous improvement based on research based best practices is the gold standard. The various committees of practitioners and experts in Minnesota and nationally believe this approach to science education is the very best way to support our students. So, what are some of the shifts? Here are the big ideas. Standards are organized in 4 strands, and woven into those strands are benchmarks that weave in the 3 dimensions. So let's begin with what's likely most familiar, the core ideas. So you know physical sciences, life sciences, and earth and space sciences. Now, more overtly intertwined than in the past, you'll see a fourth, engineering, technology, and the application of science. Each of those core ideas has some areas of focus that will also likely seem familiar. See this graph. In the first draft of the standards, and I would anticipate in all subsequent drafts, not all core ideas are present in each grade level, and each grade level invites focus on more than one core idea. You have access to a color coded progression document of standards on our website. For a quick visual review of what core concepts are placed into which grades, check it out here. You're welcome to take a pause to digest this and return to the video when you're ready. Next up, what are cross-cutting concepts? These concepts have application across all domains of science, and they provide a way to help students link and see the connections between the different core ideas. These are the cross-cutting concepts. For a deeper dive into the progression of the cross-cutting concepts, find a helpful document from NSTA here. In short, we want to help students understand how they'll see these cross-cutting concepts across each core idea, thereby unifying the science experience for students. Next up, what's all this about the practices? These are the behaviors that scientists engage in as they investigate and build models and theories about the natural world, and encompass a key set of engineering practices that you'll see are strongly embedded into the new draft of standards. These practices aim to provide more specificity to the idea of inquiry in both science and engineering. The overt emphasis on science, technology, engineering, and math helps students see the relevance of the standards to everyday life. Of the 8 practices, 4 are already strong within our current standards. 2 will be newly woven into the standards, and 2 are part of the literacy standards expected in non-ELA content. To dig deeper into the progression of the practices, please reference this document from NSTA. These are the practices. Finally, let's focus on the strands. Rather than organize the new standards by standard, they are organized by strand. The strands are what provide the cohesion for the K-12 journey. Every grade level touches each strand in some way, but there are some progressions that take a break in some grades. So strand 1, for example, exploring phenomena or engineering problems, focuses on practice 1 and 3. In the image you'll see the progression of expectations from K to 12 of practice 3 as it aligns to the first standard. You'll notice that the focus for grade K6 is in the physical sciences, then shifts to life science in grade 7, and then to earth and space sciences in grade 8. You'll also notice that the second benchmark begins in kindergarten and grows through grade 4, then takes a break in grade 5, comes back in grade 6, and then doesn't come back again until 912 physics. Within the draft from the state, there are some number errors that will be addressed in the next draft. So here's how the standards are currently organized: first by grade, then strand, then practice, then standard, then benchmark. So 7.3.2.1.3 says this: it's a seventh grade standard that aligns to the third strand, developing possible explanations of phenomena or designing solutions to engineering problems, and targets practice 2, developing and using models. This particular benchmark is aligned to the first standard under the practice. Students will be able to use diagrams, maps, and other abstract models as tools that enable them to elaborate on their own ideas or findings and present them to others. And it's the third benchmark. You'll see the parentheses at the end that helps us understand that this benchmark aligns with the second practice, developing and using models, focuses on the fifth cross-cutting concept, energy and matter, flow cycles and conservation, and targets the second piece of the life science core idea: ecosystems, interactions, energy, and dynamics. There's a lot of information in that tiny box. There's a quick reference sheet to the strands and the 3 dimensions that can be accessed here as you move beyond a cursory look to digging deeper into the standards. It's important to know that the standards are in draft. We'll have access to the second draft in mid February, and the final draft is intended to be released sometime in May. While there's a commitment to the strands and dimensions, there's much finessing that may likely take place as the committee revises the draft. Take a deep breath because we have some time. It's likely that the recommendation will be to have the new standards implemented a number of years out, like maybe 4 or 5. We know that once the standards are finalized, we'll need to begin planning how to phase in so that there are not gaps in students' learning. I imagine that the high school has the most questions as there's a whole earth and space sciences thread that isn't currently part of our required course progression. MDE will definitely provide guidance as to how the course sequence could look, but until we have finalized standards, there's no need to plot a specific course. So, what's our work now? It'll be important to understand the practices, the cross cutting concepts, and reflect on the solid pedagogy we currently have in place that allows students to figure out and explain scientific phenomena. In February, we'll have an opportunity to see the next draft of the standards, and there are many ways to share feedback with the developers. The members of the Curriculum Review Committee will show you how you can share your feedback when that's available. I'm happy to meet with teams to hear your ideas, and we'll work through these shifts together. Thanks, and have an awesome rest of your day.